Good day everyone, welcome to JD's channel. Today, we're going to discuss another topic. Don't forget to like, share, and subscribe for more tutorials. Thank you and God bless. Good day everyone, welcome again to JD's channel, and for today's topic, we are going to discuss Norton's Theorem. So let's get started. For the content, we are going to define what is Norton's Theorem. We will also discuss history of Norton's Theorem. Thirdly, we are going to discuss steps in solving problem on Norton's Theorem. And lastly, we are going to solve problems using Norton's Theorem. For introduction, for many linear circuit, analysis is greatly simplified by the use of two circuit reduction techniques or theorem. So ito na nga class yung ating na-discuss last time, the Thevenins, and now we are going to discuss the Norton's Theorem. The Thevenin's theorem is named after a French engineer, Leon Charles Thevenin, in 1883. And Norton's Theorem after an accomplished Bell Lab engineer and scientist Edward Lawry Norton. By using this theorem, a large or complex part of a network is replaced by a simple equivalent. With this equivalent circuit, we can easily make necessary calculations of current, voltage, and power delivered to the load. At ang maganda dito class, hindi na bago yung current or yung voltage or yung power na na-deliver sa ating load kapag ginamit natin yung ating equivalent circuit. Ano po, kung ikukumpara natin dun sa original circuit, yung pa din. Ano po, pinabilis lang natin at gumawa lang tayo ng simple but effective way to solve yung ating problem. Yung ating mga complex problem, lalo na yan. This type of application ensures to select the best value of the load resistance. So, ayan po class yung konting introduction natin. What is Norton's Theorem? About 43 years after Thevenin's published his theorem, Edward Lawry Norton, an American engineer at Bell Telephone Laboratories, proposed a similar theorem. Ayan, so tunghayan natin ngayon kung ano ba yung na-propose itong si Edward Lawry na to. Ayan, ano ba yung na-propose nitong scientist and engineer na to. So, indirect current circuit theory, Norton's Theorem, or ang unang tawag or ang tawag sa kanya then class is Mayer Norton's Theorem, is a simplification that can be applied to networks made of linear time invariant resistance, voltage sources, and current sources. At a pair of terminals of a network, it can be replaced by a current source and a single resistor in parallel. Kung matatandaan nyo class, yung ating Thevenins, siya naman ay voltage source in series naman sa ating resistor. Ito naman class, siya naman ay naka-parallel. Ano po? So, current source naman siya, naka-parallel naman siya doon. Norton's Theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of current source IN in parallel with a resistor RN, where IN is the short circuit current through the terminal and RN is the input or equivalent resistance at the terminals when the independent sources are turned off. Yan. So, class, kung makikita natin, mapapansin natin, dalawa lang din yung ating kailangan hanapin dito, which is yung ating IN, and then yung ating RN. Ayan, wherein yung ating RN is the input equivalent resistance doon din sa ating mga terminals. Okay, na makukuha natin na if we turn off yung ating mga independent sources. Okay, so ayan. Go now sa ating history ng Norton's Theorem. So, eto yung mga tao na nagkaroon or naglaan ng oras sa pag-aaral sa theorem na to. So, Norton's Theorem was independently derived in 1926 by Siemens and Halski researcher Hans Ferdinand Mayer. And then, siya ngayon nagkaroon ng first or unang pag-aaral dito sa theorem na to. And then, nagkaroon na din ng interest at inaral din at pinag-aralan ito ni Edward Lawry Norton. At that time is a Bell Lab engineer. Norton's Theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a current source IN in parallel with a resistor RN. Yan. So where IN is a short circuit current through the terminals and RN is the input or equivalent resistance at the terminals when the independent sources are turned off. So ayan, lagi niyong tatandaan, ito po class na yan yung ating IN and RN kapag sa Norton's Theorem. Okay, and yung kanyang itsura. Okay po. Thus, the circuit in figure A, so ito yung class, ayan, ito yung original circuit natin class, ay may co-convert natin siya dito sa Norton's equivalent circuit na ito. So, kung makikita ninyo, yung ating current source ay nakaparallel doon sa ating resistance. Yan. Yan yung ating Norton's equivalent theorem. So, we go now sa steps in solving problem on Norton's Theorem. So, in Norton's Theorem, we are mainly concerned with how to get yan yung ating RN and IN. So, to find RN is the same way we get or we find RTH. So, saan pa yung RTH na yan? Yung po yung sa ating Thevenin's Theorem. Ano po? Kaya, ito kasunod kasi nun. Ano po? Ayan. Kaya, dapat napanood nyo na yon. Ano po? Kung hindi nyo pa napapanood, ilalagay ko na lang yung link sa taas and doon po sa ating description. Check nyo lang po yung link para mapanood nyo and maunawaan nyo yung ating pinag-uusapan. Ano po? So, in fact, from what we know about source transformation, the Thevenin's and Norton's resistance are equal. So, that is, yan, yung ating RN is equal sa ating RTH. Okay? So, ayan. To find the Norton current, or yung ating IN, we determine the short circuit current flowing from terminal A to B in both circuit in figure shown. So, ito class yung original circuit natin. And then, pag kinonvert natin siya dito, ayan, ito na yung magiging itsura niya. So, dapat may makuha natin yung ating ITH. Dapat makuha natin yung ating IN. Ayan. And yung ating RN. So, it is evident that the short circuit current in figure B is yung ating IN. So, yun nga po yung ating kukuhanin. Ano po yung ating short circuit current. Okay, so, this must be the same short circuit current doon sa ating terminal AB. Ayan, di ba makapansin nyo class, dito sa ating original circuit, meron tayong terminal AB dyan. So, ayan, bakit ba natin nasabi na yung ating short circuit current na yon is the same do sa as current na dadaan dito sa ating short circuit current na to, short circuit na to. Ano po, so ayan, ito pag sinort natin class, so di ka magiging connected siya and magkakaroon niya ng flow ng current, which is yung ating short circuit current na sinasabi. Okay, so bakit siya naging equal diyan sa ating IN? Okay, so again, two circuits are equivalent. So di ba kung matatandaan nyo dun sa discussion natin ng Thevenin's, malinaw na sinabi sa atin yung meaning ng equivalent. Ano po, yung relationship ng voltage and current dun sa terminal. Ano po? Ayan. So, that is the reason. Ayan. So, kaya napakahalaga na mapanood nyo muna yung Thevenin's theorem discussion. Ano po? So, click nyo lang yung link na ilalagay ko sa baba para mapag-aralan nyo. So, thus, yung ating, ayan nga, yung ating IN is equals dun sa ating short circuit current na eto din po, yan, yung magiging itsura niya. So, yung from yung ating original circuit, ano po, then, i-short natin, ayan, so may dadaan tayo diyan na short circuit current, which is yung ating I sub N. Dependent and independent sources are treated the same way as Thevenin's theorem. Wherein yung ating dependent, pag tinon off natin yan, ano po, kung matatandaan natin, okay, sa discussion din natin ng Thevenin's, that yung ating voltage source will be short-circuited, and then yung ating current source ay ma-open. Ano po, kapag tayo ay nasa-solve para sa ating RN or yung ating RTH. And then yung ating dependent sources naman ay mananatili sa kanyang kinalalagyan. Ano po? Yan. Observe the close relationship between Norton's and Thevenin's theorem, wherein yung ating RN is equals sa ating RTH and yung ating IN is equals to BTH over ng RTH. Ayan, kaya dapat makukuha natin yung ating BTH, okay, and yung ating RN, since RTH is equals sa ating R sub N. Okay, this is essentially source transformation. So, kung matatandaan yung discussion natin sa source transformation, ayan, eto na siya yung from current na naka-parallel, then voltage source na naka-series. Ayan. For this reason, source transformation is often called Thevenin's Norton's transformation. The Thevenin's and Norton's equivalent circuit are related by a source transformation. Since VTH and IN and RTH are related according to the equation below, ayan, yung nakikita natin dyan, to determine the Thevenin's and Norton equivalent circuit, meron tayong nire-require. So, ano ba yung kailangan nating maintindihan? Ano ba yung requirements para may convert na natin ng Norton's theorem? Ano po? So, una, ayan, we need to find yung ating open circuit voltage or yung ating VOC. Yan, yung voltage na nandoon sa ating terminal AB na naka-open. And then, secondly, short circuit current at terminal AB din. Okay po, pag na-short na natin yung circuit. And then, lastly, the equivalent or input resistance or yung ating Rin at terminal AB pa rin when all independent sources are turned off. Ayan. So, para mas mabigyan linaw, ito po ang ibig sabihin niya. So, yung ating VTH, yung VOC kasi na sinasabi dyan, class, is yung ating VTH, ano? And then, yung ating short circuit current, once na yung ating circuit ay na short circuited na, so, IN is equals sa yung ating short circuit current. And yung ating RTH Okay, that is equals also sa Rn, na yun yung ating kailangan, is equals to the VTH or yung VOC over ng short circuit current. Ayan. Okay, so that would be all, class, for today's discussion. I hope na kayo ay natuto patungkol sa Norton's, sa kanyang definition, sa kanyang history, and steps to analyze Norton's Theorem. Keep safe, everyone. God bless you all, and thank you. You get something and you learn something from this tutorial, and don't forget to like, share, and subscribe for more tutorials. So thank you, class, and God you all the glory. So thank you, and keep safe, everyone. God richly bless you.